Chapter 2 covers rational numbers. We're going to start with section 2.1, which covers rational numbers. Before we begin, I want to actually go over what does the word rational actually mean. A lot of students go through math and they hear about rational numbers, but they really don't understand the meaning behind it. The word rational comes from the word ratio. Recall that you can write a ratio using fraction notation. For example, if you sleep for 8 hours in a day, then the ratio of your sleeping time to the total number of hours in a day can be written as 8 hours divided by 24 hours because you're sleeping 8 hours in a day. A rational number is a number that can be written as a ratio of two integers. So there's your definition. Rational number. So here's your vocab word. A rational number is a number that can be written as A divided by B, where A and B are integers and B cannot be equal to 0. So once again, we can take our integers A and B, any numbers that are integers, and write them as a fraction. A divided by B. It's a ratio. But B, the bottom number, the denominator, cannot be 0. So we're going to make a little chart here about what rational numbers truly are. So we're going to start with just a circle. I want you to draw a circle. And in it, I want you to write whole numbers. Now, what are some whole numbers that you can think of? Okay, I'm going to put down 2. I'm sorry, not 2. 0 and 4. We can put a 2 as well. 0, 2, 4, 8, 3. Those are all whole numbers. Then, one step back from that are integers. Integers would be, for example, like -10, -2. Then around that, we have rational numbers. So why this diagram? And once again, we can put some rational numbers. -1.2 repeating, -2/3, 3.5, 5 8/10. So when we look at this, whole numbers are rational numbers because whole numbers can be written as, for example, 2 can be written as a fraction, 2 over 1. 4 can be written as 4 divided by 1. Integers are rational numbers. That could be -2 divided by 1, -10 divided by 1. But are integers whole numbers? No. Whole numbers are a part of integers, which are a part of rational numbers. That's why this chart kind of shows you subsets of other things. So rational numbers are not necessarily integers, and integers are not necessarily whole numbers. Something you've done before are talking about terminating and repeating decimals. Just as review, a terminating decimal is a decimal that ends. For example, 1 and 5/10, -25 hundredths, 10 and 625 thousandths. All of these decimals end. A repeating decimal is a decimal that repeats. -1.333 is really -1.3 repeating. Same thing here, it repeats because the repeating bar shows us it repeats. Example 1. Write each of these decimals as a fraction or mixed number in simplest form. I'm hoping this is review, but we're going to quickly go over these. A, -26 hundredths. Notice how I just read it. 26, 6 is in the hundredths place, so this is going to be -26 hundredths. Is that simplified? Why not? Because you have to divide both the top and bottom by a common factor. I can divide the top and bottom by 2. My answer would be -13 fiftieths. The next example, 125 thousandths. So I write it as 125 thousandths. What is the highest factor you can think of that goes into both 125 and 1,000? If you thought of 125, that would be correct. So I can divide the top and bottom by 125, and that would give me 1/8. The next one, you can either write it as an improper fraction and then simplify it. The easiest way would just be read it as a normal decimal. -3 and 1/10. So we write it as -3 and 1/10. 1/10 is simplified. And the last one would be -10 and 25 100ths. What is the biggest factor that goes into both 25 and 100? It'd be 25. Divide by 25. It'd be -10 and 1/4. Example number 2. The table shows the elevations of 4 sea creatures relative to sea level. Which of the sea creatures are deeper than the whale? Explain. So if you look here, we have a whale. The whale's at -8/10. We have 4 creatures, and we have an elevation in kilometers of each creature. So the first thing we're going to do is, since the whale is in decimals, I'm going to change the rest of them into decimal form. So, -13/10. -13 divided by 10 is -1 3/10. -2 1/5 is equal to -2.2. And -2 11ths is equal to -0.18, repeating. And we know the whale then is -8/10. Now, I drew a number line to help you out if you need it. Otherwise, if you can just figure it out, that's fine as well. So let's look at the number line. If I was the shark is -0.18. That's going to be approximately right here. So there's the shark. The whale is right here. The anglerfish is -1 3/10. So that would be, if this is right here, that's -1 4/10. So -1 3/10 would be right here. So that's the anglerfish. And the squid is at -2.2, which would be right here. So you can see which of the sea creatures are deeper than the whale. You would say the squid and the anglerfish are both less than -8/10. So the squid and anglerfish are deeper than the whale.